your tubes full of water. You wanted to talk about that, if I remember.
Right.
You're the one that asked me to come on, so
Well,
I
no,
assumed you'd sorted that.
No, you said you wanted to do a one-on-one.
Yeah.
Yeah. So
Yeah,
what's that
after you
like?
kept asking for a debate.
I didn't ask you for a debate, did I? I've always said you can come for a chat anytime, Nick. Anytime.
Let me see if I can find it where you say you wanted to talk about the water level test. So
Talk about it, yeah. And then you said, oh, only you though.
if it's a one-on-one.
Nobody else would let me talk. What's that mean?
Because it was a mess last time.
Which what was?
The last time I was on a voice chat with Flat Earthers was a mess with the number of people that could talk.
Who were you on with?
You, Sleepies, and two other people. I can't remember the name.
So what are you calling us then?
Flat Earthers.
Right, and what's that?
Do you believe the Earth is round?
Nick, what
No, you don't.
is a flat earther? Tell me, please.
You think the Earth is flat, shaped like a pizza?
I can see
terrain.
I can see mountains and valleys. Can you not?
Yeah. Bev,
Can
that's
you?
being dishonest.
Nick,
You know it
it's
means
being
okay,
dishonest saying I can see mountains and valleys.
You think it's like a pizza?
What?
There you go. Pizza has troughs and valleys and all that, and has the ice
Do
wall.
pizzas have mountains and valleys on them, Nick?
Stop being intellectually dishonest, Bev.
What do you mean? Who's being intellectually dishonest? I know that mountains and valleys aren't on pizzas.
No, but there is the terrain. I'm using what's called an analogy.
Right, so
do you understand
we
what an analogy is?
We agree there is terrain, right?
Yes.
Right, and if there is terrain on something, it is not flat.
Do you believe the Earth is round?
Nick?
Do you believe the Earth is round?
Nick?
Do you believe the Earth is round?
Nick?
Yes or no? Yes or no? Do you believe the Earth is round? Or do you believe it is shaped similar to a coin?
What, is a coin round?
Do you believe it is shaped in a sphere? Let's correct my question slightly.
A sphere?
Yes.
A geometric shape, sphere, spherical.
Yeah.
Yes.
You believe the Earth is spherical?
Definitely not.
Sphere?
Absolutely not.
Go.
Do you believe the Earth is spherical, Nick?
It is a globe, yes.
Spherical?
A Blake spheroid, to be precise. But...
Okay, so there would be no way you could ever use spherical geometry on an oblate spheroid, right?
Yes, there is. You just add what's the word? Coefficient in front of. I can't remember if it's the cos sign or the.
In geometry.
Sign at this point.
In geometry, Nick.
Spherical, yes.
Spherical geometry.
Yes, you add a constant coefficient in front of. I can't remember if it's the sine or
isn't
cos
it? You need r, do you not, for spherical geometry, Nick?
Yes, but you add r sine theta or r cos theta, and I cannot remember the exact
in
combination
geometry,
off the top of
Nick?
my head.
In geometry? Have you been reading up about geometry since last time?
Oh,
right.
God.
So we'll go back to the flat thing then. And mountains and valleys, are they flat?
No, but do you believe the Earth is spherical? No, therefore, and you believe
spherical
it is shaped
geometry
is with an ice wall round it and hills and valleys and all that crap?
Talking about?
You are a flat Earth.
Sorry, Nick, what are you saying? Are you
are
deciding? Are you deciding what I think now? Or are you going to actually listen?
You have said multiple
to what I
times the description you have given is a flat earther.
No, that's
so fucking obstinate.
That's what's happened in your imagination, Nick. I've said there are mountains and valleys, and they negate any chance of flatness. However, when you say you're using geometry of the spherical nature, spherical geometry, that is the geometry of a two-dimensional surface of a sphere. So that is actually two-dimensional, isn't it?
Two-dimensional means it has no width.
No width?
Yes, there is no thickness to the surface of the sphere.
Just height,
spherical
then.
geometry.
So with no,
you'd have to do integration between two bounds.
There's no vertical component, is there? Once you've determined R, then that is the surface that you are dealing with, spherical geometry. True, Nick?
Yes, unless you integrate between 2 points, in which case you can add a
So
Add a
in
deck
my
to it.
imagination, reality, I have mountains and valleys, and that negates flatness. Whereas you go to spherical geometry that is actually two-dimensional.
Oh, Jesus Christ, you are the worst person.
What? Because I have truths and facts.
No, you think the Earth is shaped like a pizza with an ice wall round it? which would
I
be
do
the
not
crust,
do that.
hills
Do
and
you?
valleys, which are the toppings.
Do you
and
think
it's
you
circular
can
in
divine
shape. That's
people's
what you
thoughts?
believe. That's what you have said multiple times.
I have not said anything like that ever, Nick. Like
Yes.
you'll say that again, like, and then not be able to show us where I actually said that, won't you?
It's because it's ages ago in a massive Twitter thread.
Oh, right. So you can just sort of you vaguely remember it, can you?
Yes, I can
When I said
vaguely
that,
remember.
okay,
it.
right. So-
Let's see. Flat Earth. I can do a search with your name. You're literally on some keep advertising called something called Flat Earth Debate. So there's one thing.
Flat Earth debate. Nathan
Yeah.
Thompson or Nathan Oakley? Which one?
I don't know. You're the one. You shared the link. It's live now. You shared 21st and 22nd of April.
Yeah.
So there's one thing.
Yeah. I shared a
let's
link.
see.
Brilliant.
January 29th, Flat Earth is the end conspiracy. Let's see. Here you go. No, I've gone to your tweets from 2019.
Oh wow! How far back? Like a year?
I literally just scrolled to the end. It didn't take long.
You're doing a word search for it, and you're having to go a year back. Oh yeah.
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 Oh, thanks.
Wow.
Yeah. It's like, doesn't bring up everything. There's like 50 responses here.
Right.
Because Twitter's
When you
search is
find
pretty
it,
bad.
take a screenshot of it and put it in the live stream text.
So,
box.
can you explain why you keep using the hashtag Flat Earth if you don't believe the Earth is
It's a
flat?
great trigger, isn't it? Triggers absolute muppets like you.
You
and
think
that
the
go
Earth is
into
flat?
some sort
You're
of...
just an intellectually dishonest twat muffin. You really are. That was a terrible insult. Yeah, that was terrible,
Yeah, it
even
was,
by my
wasn't it?
standards. Yeah, I'll give you that. That was pretty bad.
Right, so you've been...
What?
like,
Sorry.
Sounds like you've
What's
been
it with
doing a
all
bit...
these posh? Sorry, I'm just gonna. What's with all these posh twats like Stephen and Nicholas? Why are they so wet? I have no idea what that means. Sorry, it was just something that popped up on my screen from the text chat, and I saw my name, so it drew my eye.
Where's that? Where does it say that?
It's in like the live stream text chat. Sorry, it just drew my eye. Drew my eye.
Okay. Oh, you mean you think that's you? Yeah. Does that
What?
sound like you? Posh.
Being a posh twat, yeah,
Yeah.
it does pretty much sum
Oh,
me
right.
up.
Okay.
First to admit I'm a posh twat. Like, that's not even incorrect.
Nice. So you had a good school then, upbringing. You've had plenty of...
Oh, my secondary school was one of the worst secondary schools in the country. You can look it up. Bexhill High, 90 people to a classroom. Ugh, that was a terrible school.
Okay, so... What, did you actually come to hear the water level test?
Yeah, I did.
Well, I noticed you'd done a bit of geometry and all of that, right? But, I mean, before we go with the test, we still have to do an understanding like that I don't think we got last time. You know, straight lines don't bend.
Okay, so let's start with how you'd actually derive an experiment.
Well-
What expected results would you expect to see if the Earth was flat
We
from your
have,
water
we
level
have
test?
to understand, first of all, what a straight line is, Nick. Because if we
Okay.
don't determine that...
Straight line doesn't bend, we'll give you that.
Brilliant.
Go ahead. What test results would you expect on a flat
And,
Earth
you know...
with no gravity?
We need to do another one as well. We just need to finalise the geometric sort of thing. A
Level does curve.
A perpendicular is two straight lines, right?
No, you can form perpendiculars to a curved surface.
You can't, because then one wouldn't be perpendicular to the other one, would it?
You can form perpendiculars to a curved surface. You form a point at the instantaneous point on the curve.
Well, but that when you say a perpendicular, like when horizontal and vertical are perpendicular, you don't need to say which one. is perpendicular to the other. Now imagine one of them was a curve. Then
Yes,
would
you
that
can-
be perpendicular?
You can do perpendiculars to a curve. You can draw.
And you
90
can do a
degree
curve that's perpendicular to a straight line, can you?
lines. Yes. You have the end of
Yes.
the curve at 90 degrees.
So you
Yeah,
just
you have the
basically
end of
just
the
draw
curve.
a circle then on a straight line and go, hey, perpendicular.
No.
What?
Perpendicular is 90 degrees.
Yeah, you need
So
two
you
straight
need the end of
lines, don't you?
No, you don't.
Yes, you do. Can you show me if I go and get
Hang on.
my
I've got paint
definition
open. Let me
of
2 seconds. 2 seconds to draw a perpendicular line.
to
a
draw,
circle.
or can give us a definition of it, like so you know.
Perpendicular line is at 90 degrees.
Yep, I can give you the exact definition from
Okay.
Euclid's Elements.
That is at 90 degrees.
That's that. Is that not the new graph? That x and y axis on the graph. I think I did that for you, didn't I?
No,
I did.
that's
I
90
labelled
degrees.
one y and the other one x because that's how you imagine your horizontal. But
That line is 90 degrees to the circle.
it doesn't look like it because you see my one that's just above it. When a straight line standing on another straight line, that's one straight line standing on another straight line. Now, you don't seem to have the other straight line. You've got one straight
Can you
line connected to
Straight
a
line
ball.
standing on another makes an adjacent angle equal to the other. Each of these angles curves a right angle. Please point to the point in that where it says it can't form a right angle to a curved surface.
Because it says when a straight line standing on another straight line. That's two
That
straight lines.
doesn't exclude curved lines at
It
all.
doesn't say two wibbly wobbly lines crossed by.
Where does it exclude it?
That's not how the
doesn't.
definitions in Euclid works, is it? It's an axiomatic system, isn't it, Nick?
Unfortunately,
You don't
your
have to
point
say
you're
the
trying to make-
negative of absolutely everything.
If
do
you couldn't form. So, do you agree that on any circle, any point, I could draw a tangent to the surface? Do you agree that?
To the surface of the. You mean the
To the surface
circumference?
of the sphere. I can draw a tangent to the circle.
Yeah, tangent on the circle, wouldn't it? Touching
Yes.
at one point. Yes.
Yes. Now, do you agree that that's a straight line?
A tangent has to be a straight line, but we're getting sort of off the side of geometry.
No, we're not. No, we're not. Do you agree that on any point around the circle, I can draw a tangent?
Of course you can.
Yep. Do you agree that a tangent has to meet the point of a circle when that point of the circle is running parallel to the tangent?
It just all a tangent is a straight line that touches a curve at one point and one point only.
Yep. It has to be parallel to that point it touches.
No, it just touches the point. It doesn't really matter.
No. It's parallel to that. Please draw me a line that touches one point on a circle.
How can it be parallel to how can a straight line be parallel to a curve, you muppet?
Because you have infinitesimal, you get dx of a circle. This is going into integrals. That's not a good idea with you. Circle can be made. A circle is made up of effectively infinite number of small straight lines. Now you can draw a tangent to any point of those lines.
Yeah, and a tangent is a straight line that touches a curve
It
at
is
one
parallel. Yeah, and
point.
parallel.
Can't be parallel.
point.
Don't talk ridiculous here.
I'm not, Bev. It's parallel to any point on a circle.
No, it's a tangent to the curve.
Yes.
It's not
Which
parallel
is
to
parallel.
it, you muppet.
It is parallel to that point on the curve.
It's
It
a
touches at
tangent,
a
that's
single
it.
point. Yes, and the tangent is parallel to the point of the curve it touches. Deny it as much as you want. That's just the fact. It's parallel to the point on the circle it touches.
All right. So, which geometry are you using to give your definition of a perpendicular?
No, that's just straight Euclidean geometry.
Right. So, when they say vertical
Point.
and horizontal are perpendicular, what do they mean, Nick?
They are perpendicular. They're two straight lines, but this is irrelevant to the fact you can form a right angle to a point on a circle. Because if you're saying you can't, you realize that gets rid of all of optical physics is gone. Parabolic mirrors, lenses, if you can't measure an angle to a straight line to a curved surface, they're all gone. That stops working.
Can you find me anywhere that states you can draw an angle to a curve?
Yes, let me find a ray diagram for you.
You know what a ray is? Are we talking a mathematical ray, Nick?
This is a light ray optic.
What's a ray,
Sorry.
Nick? Tell everybody. I'll tell them. Should I? It's a straight line, isn't it, Nick?
Yes.
Yeah,
And it moves
yeah.
on curved surfaces.
What a straight line on a curved surface is?
No, a ray is a beam of light in this context.
It's a straight line, isn't it?
Yes, but it doesn't have to meet a flat surface. You understand that?
Where's the angle measured from, Nick?
The instantaneous point of the circle it meets.
The tangent.
Yes.
Yeah, so that's a straight line, isn't it, Nick?
No. Do you understand that the point of the circle it meets is not in fact a tangent? Tangent is one way of easily measuring the angle at that
Tangent's
point.
a straight line, isn't it, Nick?
But shrink the tangent down to infinitesimally small.
It's a straight line, isn't it, Nick?
Your maths is worse than fucking 6-year-olds I tutor. Jesus Christ.
Are you trying to redefine straight lines now, Nick?
Hang on,
No,
can
the
we
tangent
just,
is a straight line, but it's irrelevant.
Can I just say that?
You can measure off of a circle.
So he
Nick,
did
The fact that
mute.
this
Nick,
tangent is parallel
Nick,
to a point
Nick.
of the circle.
He did mute me, didn't he?
You've muted Emma, haven't you?
Possibly. I
Right.
don't know. I muted everyone.
You
Unmute
can't
Emma,
speak-
please.
You
Ray of
can't
sunshine.
speak in a condescending
Why?
Mute it.
I'll do
tone
it.
like
I'll do
that
it.
in
there
your
you go.
posh accent, and then
Yes, I do
turn
have a posh
around,
accent.
and then turn around and use language like that. It doesn't go together. I mean, honestly,
It's not very
school,
respectful, is it?
what finishing school taught you that?
You think I went to a finishing school?
Well, the accent that you put on, that we can all do if we wish to,
Well, this is growing up in the south of England. The
keep
accents
it-
I have.
keep it consistent.
No, I'll speak how I speak.
We'll try putting some respect in it.
Oh, this guy's funny.
He's a clown.
He is a clown.
So, can you remember where you were at before you started getting?
No, I
triggered?
completely lost the point of where that was.
Yeah, you were trying to say something about tangents going in infinitesimally small, but still being a straight
yeah.
line. weren't you?
Tangents are drawn to the parallel to any point on a circle.
It's
That's how
just
a
a
tangent
line
is.
that touches a curve, Nick. Come on.
Yes, and they are parallel to that point they touch.
Oh, don't be silly. You can't be parallel to a curve. You can't have a straight line parallel to a curve.
You can parallel to a point on the curve, not the entire curve. The point they
Oh,
touch
what's a point?
specifically.
Nick, what's a point in mathematics, geometry?
In this case, an infinitesimally part of the line segment, infinitesimally small part of the line segment.
Oh, is that what a point is? Is that defined in which geometry is that defined in?
That's just what a point is. It's a infinitely small point.
Do you want me? I'll get my book again, should I? Definitions, Euclid, elements. A point is that which has no parts or which has no magnitude. So it's nothing,
Yes.
Nick.
In
So
infinitesimally
how
small.
can something be parallel to nothing?
Infinitesimally
Nick, please.
small. Bev, your education in maths, what is it? That book? Anything more?
Euclid's elements, Nick.
What's your education to actually be able to understand what you're reading?
I can just.
That's
read.
an appeal to education fallacy.
Yeah, don't worry about it, Sleepy. He's all right.
I'm trying to show that you don't actually understand what you're reading from.
I don't understand the words
A
that I'm
point-
reading.
A point
Is
an
that which has no
infinitesimally
parts.
small thing. Yes, no magnitude, infinitesimally small. These are the same.
Yeah, not there. Nothing.
That's not
Echo
how-
Tony.
That's not how they work. A point is infinitesimally small, but it's still there. Why would you define a point?
How
Why
would you have something
why would
parallel to
point-
that, you muppet?
Teaching you maths. Fucking
You're
hell.
not
Terrible
teaching maths
at it.
at all. So far, we're stuck on a straight line and perpendiculars.
Yeah, you can have parallel lines to a curve. They're just parallel to a very small part of the curve, not the curve as a
You
whole.
can't have a straight line that's parallel to a curve, though, can you?
You can.
Nick.
It parallel to an.
Oh, Nick,
infinitesimal-
come on.
Oh, it's-
A straight line parallel to a curve, you can have that in your mind or in reality? Or in your geometry? Which one?
It's parallel to an infinitesimally small part of the curve.
Can I ask
Because
you which
if you draw a
geometry
line-
are you using, Nick?
This is just normal Euclidean.
Right, okay,
Now,
so we are using
answer me this.
Euclidean, so my definitions are good then, right?
Do you agree, listen, do you agree that a tangent touches at an infinitesimally small point of the circle?
Yes, it just touches
Okay.
the
Now,
curve
if
at
you draw
one
a
point.
line- if you draw a line from the center of a circle to the tangent, so across the radius, that's 90 degrees to the tangent, correct?
It can be, yes. Two straight
I'd
lines.
really like you to see, I'd love you to see you draw a circle where that isn't the case.
Two straight
That's not
lines,
a
right?
circle.
The radius
Yep.
and
Now-
the tangent. Two straight lines.
Now, listen, that line is touching exactly the same point that the tangent is touching on the circle. And it's parallel to the tangent. There you go. You
two
have-
lines, the two straight lines are perpendicular, right?
Yes.
Okay, so the circle, the curved bit is irrelevant in the fact that the two straight lines
No.
are perpendicular to each other.
Jesus
Thank you.
Christ, I hope you don't breathe. The tangent
Nick,
is parallel
Nick,
to a point
Nick.
on the circle.
Nick, why do you hope I don't... What?
I hope you don't breed, have offspring.
Have you?
Because,
Have
God,
you, Nick?
No,
got
I'm
children?
23. No,
Wow,
I'm
how
23.
rude.
I have two children, Nick.
I feel sorry for them.
Yeah. Why?
Because they're going to really have some trouble with you as a dad.
Why?
Says the 23-year-old. No,
Nick,
it's all
I feel
little
sorry for your
jacked up
parents,
twat.
but I'm not judging you by
When it comes to
them,
physics
so
and maths,
just
I know
keep
what I'm
it,
talking about. That's what a
keep
master's
it to
degree
the
will
subject
do.
matter, Nick, you idiot.
He's muted you.
Yeah.
No, I haven't. I can hear Emma. I was responding to her.
Yeah, no, I
Yeah,
wasn't
someone
talking
else
about
was
Emma.
talking
Oh, yeah, I've muted
over
the
the
other
top
ones.
of me. But talking about you're 23, you know nothing.
The master's degree would disagree. I know quite a bit. Physics and maths.
Master's degree in physics and maths.
No, master's degrees in physics. You happen to pick up quite a lot of maths while doing that.
A master's degree in physics is gravity a force, Nick?
He's not. He's muted
He
you.
can't hear you.
Is gravity a force, Nick?
Gravity is a fictitious force or inertial force, or there's the French word which I can't pronounce for what it is. It's a force that presents itself in inertial reference frames.
It's an effect. Tell him it's an effect.
It's an effect in it, isn't it, Nick?
It is not a force, but it acts as a force in the correct reference frames.
It's an
Similar to
effect,
how
isn't it,
similar
Nick?
to how a mug is not a paperweight, but it can act as a paperweight if put on top of paper.
Yeah, and go on, carry on. An effect can do what?
Acts as a force.
The effect acts as a force.
Hmm.
Nice. So the effect
Is it
is an
inertial force?
actor.
What?
Yeah. Okay. So is
Depends on the reference
is
frame.
it that effect that you are going to cause straight lines to bend in a moment?
You're going to go on about how the water level will be flat, but unfortunately for you, in both the globe and flat Earth ideas,
You like
the
that word, don't
water
you?
level would be flat. The water level would show the same results, and therefore the water level experiment is pointless.
Horizontal. Oh right. So you think what it?
Yes, because the water level under gravity follows gravitational equipotential.
Okay. And that would make it horizontal, would it?
Yep, because you get a curved equipotential equidistance from the centre of the Earth all the way round
All the way
So you'd
round
end
a
up-
straight line.
the Earth.
Yeah. And that
So you end
that
up
would
with
make it
gravitational
horizontal.
equipotential. It would make it horizontal to the point on the Earth it is at.
Okay. Well, see, that's the whole point of my test. If you like,
Your test would show the same results for both globe and flat Earth, and thus is pointless.
Right, so it wouldn't be able to show a curve. Is that what you're saying?
I have no idea what you're trying to question there.
Well, a water level establishes a horizontal plane. Now, my test would go to show that the horizontal plane was horizontal.
It follows gravitational equipotential.
Yeah,
Yep.
but
Which is
you're
not
saying
not
that
a-
that horizontal
flat.
is what would be expected on your spherical...
No, you'd expect the same results on both.
Yeah, horizontal.
No, you'd expect them both to appear the same.
Okay, right. Can I just run you through some logic then? Right?
I
You know...
doubt you're capable of it.
Oh, right, okay. Well, you know how logic works, right? Antecedent
No.
consequent relationship, right?
Oh my god. Go on, go
Right.
ahead.
So if the Earth, as you say, is a globe, spherical object, P, then the surface of liquid water must curve. Q.
Yep,
Yeah. Right.
true.
Okay. So you're going along with that. That is a valid statement, right?
Yep, that's true.
And then you could say that modus tollens for that particular statement would be to say that the water level is a tool that establishes a horizontal plane. Right.
Incorrect.
That is correct, is it?
Incorrect.
Oh, it's incorrect that a water level...
It will
the
show
tool
you. It will show
establishes
you
a
the
horizontal
point.
plane of reference.
It will show you the point at which gravitational potential is equal at both ends, which on a small scale is the same or approximates to a horizontal plane.
Right. Well, that is my test, though. I mean, have you looked into it?
Yes, your test would show the same results on either a globe or flat Earth and is
Okay.
therefore worthless.
Right. Let's say, though, but it goes 2 miles,
Yeah.
right, from end to end.
Yep.
Right, now-
Gravitational equipotential goes all the way around the planet.
Okay, but that's a
It doesn't
horizontal...
matter how long you make
It's
it.
a horizontal plane of reference between them two
Mm-hmm.
water levels, right?
On a small scale, you can approximate it to
Okay,
that.
but it's 2 miles apart, this. These two... This pipe is 2 miles
very
long.
small.
That's very small. Right, okay,
Yes,
but...
it's the scale of the Earth, yes.
But if
that's
you
very
just
small.
imagine, right, there's a horizontal plane of reference that goes across. Now, what are you saying would happen to the water level in the centre of that tube of water? You know, like, because it's only at the ends. So what would happen in the centre, like a mile into the centre?
It would fill it because it's the lowest point of gravitational potential energy because it's lower than the ends. P
It's-
equals mg
it's
delta
lower.
H. Lower with respect to the equatorial gravitational potential, lower with respect to its distance from the centre of the Earth.
The water level across in the middle of that 2 mile water level tool, you're saying would be lower.
It's closer to the centre of the Earth.
Yeah.
Yeah. So water finds the point of lowest gravitational potential energy. P equals mg delta H. You reduce delta H to find the lowest point.
Yeah, water flows downhill
Yes, it's effectively what that is.
to find a horizontal condition.
No, to find the point of lowest gravitational potential energy.
Okay, which is level.
No,
What water doesn't find its level then.
it is the lowest point, which to take that surface, you will form a level surface. But that's not what water tries to find. It doesn't try to find a level surface. It just happens that a level surface is the lowest gravitational potential energy.
Yeah, I get that. So water will always flow until it reaches its equipotential horizontal condition, as they call it. Yeah,
Sorry,
when
say
it's
that
at
again?
rest, it'll find its horizontal condition. The water
No.
in the level. Yeah, it was. That's how water levels the tool works, isn't it? They find a horizontal.
So I'm trying to assemble something in the background here. Sorry, I'm doing something else in the background for work.
Wow. What's that?
I cannot say.
Oh, secret.
Or more accurately, I don't want to talk about what I do for a job.
Oh, okay.
Because that's not for the internet.
They'd be a bit upset with you not knowing what a perpendicular is, would you?
No.
Oh.
My boss knows I do this. So,
Your boss knows you do this.
yeah.
Oh, you're not gonna show him this one, are you? Did you show him your last one?
Yeah.
Yeah.
He found it funny that your guys were total tits, to be blunt.
Did he? Does he think perpendiculars go to curves?
They can do.
They can
You
do.
can form
Well,
right angles
you know,
to
when they
curves.
do, like, or supposedly you think they do, would that make all right angles equal?
What? All right angles are 90 degrees.
Yeah, but
What?
if you was to have a line to a curve, would all four of the right angles be equal?
I have no idea what you're trying to say there.
Talking about
What?
geometry, mate.
Yeah, no, I have no idea what you're trying to say. Rephrase it.
All right angles are equal. You said that. It's an axiom within Euclidean geometry.
Yes.
Right.
I have no idea what question you're trying to ask.
Well, you draw a line, then you say you can have a perpendicular to a straight line.
Yeah.
Yeah, well, if you have a perpendicular with a vertical and a horizontal, that's 4 right angles, isn't it?
What? Sorry? You might have to draw this out. I'm not quite getting what you're trying to say.
You want me to draw a vertical and a horizontal meeting and 4 right angles.
Oh, I see what you mean. Sorry. I was getting confused what it means. Yes, yeah. I see
And
what you
all
mean.
4 of those right angles would be equal, wouldn't they? They'd all be exactly the same. There would be.
Yeah.
That's what it is about right angle, and they're never
Yes, that's
different,
a
are
right
they?
angle. No, they're always 90 degrees.
Right. So let's draw a straight line up and down, and then let's draw a curved line to it. Let's go the curve. Let's go a curve
Oh,
downwards.
you really don't understand maths.
I don't understand maths. Are you gonna explain to everybody then how you can have all 4 of those right angles equal if you have a curve there?
There's nothing needed to do with 4. If you draw a line that is at 90 degrees to a point on a curve,
Perpendicular.
yes, you have a perpendicular right angle on a curve.
Yeah, and
Do
then
you think you can't measure angles off a curve?
You extend that line like you're allowed to do in postulate 2, Euclidean geometry.
Do you not believe you can measure angles from a curve?
You can't. You need 2 straight lines for an angle.
You can't measure angles from a curved surface. Holy shit, that's
You need a
stupid.
tangent, don't you?
That's fucking stupid.
Yeah, Nick.
You can measure angles from a curve. Do you understand what a parabolic mirror is?
Oh, we get.
You know what a parabolic
what have
mirror
you got for anything like this? Have you got anything? Angle.
Yes, you know what a parabolic mirror is?
There we go. There's an
Can he
angle.
cite it, Bev?
Yeah, can you
Or
cite
is he just making
cite it,
claims?
or are you just talking words, please?
I'm going to explain it to you. Do you know what a parabolic mirror is?
No, it
Come
needs a
on.
citation.
Do
needs
you
a
know what it is?
citation.
If you
Your-
don't,
Yes,
your
it's a
words-
mirror. Okay,
Your words count.
yeah, but
for
what
nothing.
particular about it?
it's a mirror.
not
It's,
just-
parabolic and it's a mirror. What is it?
Yeah, so it's a curved mirror.
How many straight lines has it got?
It's a curved mirror.
Right. So
Now,
does it have any straight
if-
lines on it?
No, it's a curved mirror.
Oh, right.
If a
brilliant.
light
So we're
ray
not-
hits it,
I don't know why we're
listen.
talking about.
if a light ray hits it, we can tell you at what angle that's coming off.
Yeah, because it's
What angle?
Yeah.
That light ray is going to come off. But to do that, we need to measure the angle the light ray hits.
Yeah.
So we can measure angles.
That's a
to
straight line, right?
One of them is, the other one is curved.
No, the other one, it comes off it at
light
an
ray-
angle. That's
the
the
light-
angle that you're measuring. The 2 straight
The
lines.
light ray is flat. No, you're measuring from the surface of the mirror. The angle of incident is measured between the mirror and the incident
No,
light
it's,
ray.
it's the light that it comes in and then the light that it goes out. It's the angle between them two. Straight
the angle
lines.
of incidence. Angle of incidence.
Oh, come
Do you
on,
know what
Nick.
the angle of incidence is?
Nick, where
Answer the
have-
question.
Where
Define
have
the
you-
angle of
Oh,
incidence.
Nick,
What's the angle of incidence? Answer the question. I'm not letting you go. Angle of incidence. On a mirror. What is it? Don't know?
Nick, we're talking about measuring angles, and why
Yeah,
are
we
you
are.
measuring
We are.
and dicking about with a mirror?
I'm trying to explain to you.
No, Get a
No,
picture.
I'm using a real world example
Get
here, Bev.
a picture
I'm using
and
an
show
example.
us
I'm using an example.
parts of an angle. The corner
What?
point of an
Parts
angle
of
is
an
called the
angle?
vertex, and the two straight sides are called arms. The angle is the amount of turn between each arm.
You're a total cock. Whoever said that? Yeah, pretty accurate. I'm also a cunt if you want to go there, but you can measure angles to curved surfaces.
Where does it say that, Nick? You find me a citation, please, where it
Can you
says
measure?
you can
Do you know what-
measure an
I'm giving you
angle
a
to a
practical
curved
example.
surface.
I'm giving you a practical example: a parabolic mirror and the angle of incidence of a beam of light.
Show us.
What, the parabolic mirror and measuring the angle?
Show
of incidence?
me how you measure an angle to a curved surface.
You take the tangent line where the tangent would be,
Oh,
and
the
you measure
tangent.
that angle. Yes, that's the simplest way to do it.
That's
You
a
can also
straight
do it
line,
with-
isn't it, you muppet?
But it's the angle to that point on the curve. It's to that point on
It's
the
like
curve.
two
the angle.
straight lines, and the angle is the bit between them.
You could use a tangent to make it easier, or you can do integration. But I'm not explaining integration to you.
Because
That
you
is not
probably
fucking worth
couldn't.
it.
Let's just stick to practical,
Okay,
realistic.
I can't do integration. Let's fucking go there. Integral of e to the x.
Nick,
Integral of e to the x, Bev. Let's go there. Integral of e to the x.
this is
Integral of e to
geometry.
the x.
Nick,
That is geometry.
Come on.
Integration is geometry.
with a compass and a straight edge, right?
Oh, you are fucking boring. You do not grasp anything. You really are stupid.
I'm not the one that's struggling to work out how to measure an angle, am I?
You're
You
not
can
the one
measure
that's
angles to
struggling to
curved
cite a
surfaces.
claim either, Bev. It's
Like-
him that's struggling to cite his own claim. All he does is make claims and
Beyond
opinion.
ridiculous.
He's just opinionated, posh
Now, the tangent
idiot.
meets at a parallel point on the circle.
But he still can't cite it.
Measuring the difference between the tangent and the line is the same as measuring on the curve. Just because you name call doesn't make you right. No, but it's fun.
That's what a child says. And my
Yeah, do you
daughter,
think
listen,
I
my
honestly,
daughter,
what about my behaviour makes you think I give a fuck about what you flat
my
earthers
daughter
think?
listened to you for all of 5 seconds, and she went, "Oh, he sounds like a poshy."
I am. That's not
Yeah.
an insult. I am posh.
Nice.
Yeah, but
No,
are you really?
You just think you're
Yeah.
posh.
You went to
You
school.
just-
Where did you go to school again?
Bexhill.
Terrible school, but then let's point out the universities. Top 16th and then 14th, my second university.
Okay, so you weren't born posh. You just took on the role of poshy
No,
because
Being
you
born in
decided you
South
wanted
Africa
to.
have a posh
You wanted
accent.
to be a condescending
No.
little twat all your life.
being born in
Brilliant.
the South, you pick up a posh accent. It doesn't matter where you go.
No,
This is just a Southern accent.
no, it's not.
What an idiot. What a total
Oh my god, you're
Lunatic.
23. You have a lot to learn, young man.
He does, doesn't he?
Bless him.
But
Ah,
citations,
let's see.
like how to
I
give
really don't give a
citations would be a
fuck what
good
you
start.
think. You're
He
dumb
reckons
as
he's
fuck.
been to university,
So why would I care?
but he can't give a citation.
Who's 23?
This
Bless him.
idiot.
Nicholas.
Ah,
Yeah,
and
Oh.
your
he
education.
He thinks that swearing at people and calling them names is.
Marlena, he's
Find it
muted
funny.
us all
No,
as
no,
well.
it's not grown
Marlena,
up.
I
so
don't
he,
give a
he
fuck.
can't hear
There's a
us.
difference.
Yeah, you guys, you won't be able to speak to him because he's muted you all.
Can I just check that, Nick? What sort of do you think you can do to this water level test? You say there would be no difference, right?
Yeah.
Okay. I
Because
can get you
the
on
water level will
record for
form
that.
Gravitational no, there won't be any difference because you don't believe in gravity, density, or whatever you explain it with. But line of gravitational equipotential, which is where the surface of the water will form, is a curved surface following roughly
It's horizontal.
an
It's a
equidistance.
horizontal plane.
No, I'm explaining the two different models here.
Yeah, but
Yours
my
seems
test
flat
will
because whatever.
show a difference, won't it? You're saying it won't show a difference.
So you believe. So what results do you expect to see if the Earth was flat? What are your expected results?
Well, there's mountains and valleys, so you best fix your P.
If the Earth is okay, what results do you expect to see from your water level experiment?
The water level is a horizontal.
So both ends are at the same height. That's what you expect to see.
Yes,
That is
and they
exactly
were
what you would see on the
horizontal. Yeah, but what my test does, because of the clever, very clever arrangement of the way I've set them up, there's another one that checks the centre to find out that that is also the same.
Yes, it's gravitational potential, but
Horizontal.
What?
Yeah, straight
No,
line.
it's not.
You
It's
can,
a curved surface.
You can draw a straight line all the way across them, like geometry. That's what it's for, Nick. That's why we've been so keen
What
on
are
the
you
geometry
using?
that backs this.
What distance are you using between your
2
between your 3
miles
points?
across the big
2
one.
miles? And what are you doing to show that the one on the extreme end are both horizontal? What are you using?
A water level.
So you're using a water level to prove a water level.
Yes.
That's not valid.
Well, why?
You're trying to prove the extreme left and extreme right are the same. They're on a horizontal plane.
Yeah, horizontal.
Yes, you're trying to prove this. You have no continuous way of connecting these two.
There's
They are No.
three. There's three
The one in the middle
different
doesn't
water
matter.
levels,
It is a
and they are
continuous
going
way.
to be next to the canal to reference against the canal.
That's not a reference
Why?
because you're having the same problem, gravitational equipotential.
Wait, so
Your
you're saying it's
doesn't-
already curved then? You're saying what we imagine already, right now, as a horizontal frame of reference, is actually curved.
Curved and approximated to horizontal on the small scale.
Okay, so
Because
what
of that is
everybody
minuscule.
imagines horizontal to be as a straight line, you are telling them that they're wrong, it's actually curved.
On a small scale, it approximates to horizontal because the Earth is fucking massive.
Okay, so that's your XV. So people think that horizontal is a straight line, but they're wrong. It's actually
Horizontal is a
curved.
straight
Can you
line.
tell us how much it curves?
I wouldn't have that maths on the
Right,
top
so
of my
you
head.
don't.
I'd have to-
Right, so it curves, but you haven't got a clue how it curves, and
It's
it's
arc cosine
definitely
cos
brackets.
theta minus r something or
Yeah.
another.
Yeah.
I don't remember off the
Okay,
top
so
of my
you've
head.
got an equation to say how.
Yes,
this
ray of
horizontal
sunshine.
line
The Earth is fucking
curves.
massive.
Right. Okay. So and
No,
that's,
it's
that's
not
your
8.
secondary.
Sorry. Let me address this. Mandela effect. It's not 8 inches per mile squared. That is a parabolic formula, not a spherical formula.
I didn't
That's
say
not
anything. I
correct.
didn't say anything.
No, I was addressing the. Oh, well, I misread that. Yes, I'm dyslexic. The Morelia, however that's said. I can't
Marlena.
pronounce that effect. Marlena effect. Thank you.
Yeah.
Yeah, that's a parabolic formula, not a spherical
Okay,
formula.
but that's
It's
what
not
that's what
correct.
Jesse Kozlowski says. 8 inches. 8
I have no
inches
idea
per
who that
mile
is.
squared. You don't. He's one of your surveyors, mate.
8 inches per mile squares works on a very small scale
Well,
approximation.
Jesse Kozlowski. That's what he says. That's what he cited. I think he's
Small
measured
scale
it.
approximation.
McToon says he cited Jesse Kozlowski as one of his R measurements.
It's a
so
small scale
he must have
approximation.
measured it.
It's
Yeah,
a
I don't-
small
what
scale
sort of scale did
approximation.
Jesse measure it on?
I don't know the scale that works to.
Oh.
I don't use that. I use the actual formula when I need it.
Oh, so you don't actually use any measurements? You just use a calculation of a
The
formula.
Earth has been measured.
By who?
I've measured it. You can do it with 3 sticks and some rulers.
McToon
It's not
said
difficult.
Jesse measured it.
It's not difficult to measure.
And
3
Jesse
sticks and a
measured.
ruler.
Jesse said he measured 8 inches per mile squared.
Over a small scale
But you-
approximation.
Yeah. So is it
But
or
it's a
isn't it?
parabolic formula.
Right. Is it or isn't it then? How big?
A small scale approximation that works. It's
Is-
a parabolic formula.
is
The
that
Earth is
8
not shaped like a
inches?
parabola.
Is that 8 inches per mile squared? That's nearly a parabola, somewhere around that. Is that what?
So,
people
whoa.
call
The Earth is
horizontal?
nearly a parabola. I'm sorry. Did you just say the Earth is
Did-
nearly a
Nick,
parabola?
Is that what you imagine horizontal to be? That one that's not 8 inches, but something like that, right?
The Earth is massive,
Right.
right?
And that.
So on a
bends
small
horizontal
scale,
lines,
on the
does it?
human scale of things,
Yeah.
things will appear to be flat because you cannot perceive the absolute massive scale of the planet
Okay.
from on it.
So horizontal, we perceive horizontal to be a straight line because it's big.
In the case of the canal, horizontal itself, as mathematically defined, is a horizontal line. The canal, however, appears to be horizontal because of the scale you can see it on.
Okay. So my test, right, that is there to see if there's actually a curve in it, because that's what it does. My test will find out
Unfortunately, it
if there's
doesn't.
a curve. It does.
Unfortunately, it doesn't know because gravitational potential changes. As such, you do not.
To
show
make
anything.
that curve look like a very straight line that we call horizontal.
The thing is, you have no reference between your left and right ends. There is no reference. You're not putting a laser across them, which would be a good way to do
Yeah,
it.
you don't. With the water level, you don't need a line of sight. That's one of the best.
Problem is the flat surface of the water will form to gravitational equipotential. That is your problem.
Flat surface, you say?
No, it will form to gravitational
Yeah, but you said
equipotential.
flat surface, didn't you?
Yes, of the water, the very
Like,
small water in the
so a
tube.
flat surface doesn't curve, does it?
Bev, you're talking about a scale of approximately what, a centimetre or two on your tube.
So flat. So okay. So flat curves if it's big.
No, you can approximate things to flat on very small scales,
Right,
because
so what
the
does-
amount of curvature is
What does
imperceptible.
flat mean, though? To
Are you
you?
seriously asking that question?
Yeah, yeah.
It's a
Like-
straight line.
Oh, cool. So there's no curves in a flat then.
No, but the Earth isn't flat, and neither is your canal.
It's horizontal plane, right?
No, it's not.
What?
It follows gravitational equipotential. Your canal follows gravitational equipotential.
Really?
Yes.
It,
Unfortunately, your experiment will show the same results for both. I congratulate you for doing an experiment. That's good. It's a lot more than most people that believe whatever.
but
the fuck
you
want to
don't
say.
think it will prove anything.
It will show the same results for either model, and
Right, so-
therefore it doesn't prove
okay.
anything.
Right.
That's the problem.
Brilliant.
You are
So-
showing the same results for either thing.
Right. So you're saying you can't tell the difference between a straight line and a curve.
No. Your water level will not show a difference. Your water level test will not show a difference because you have no reference, linear reference between your left and right end on your whatever fucking not disk planet you think it is. Whatever pulls it down will show it flat. Now on the globe, it's gravitational equipotential that this water surface will form along. Now this matches the curve of the Earth. And that's the problem you've got. Your experiment will show the same on either situation.
Well, experiment.
Yes.
So you think it's an experiment?
Test, experiment, whatever you want to call it.
Which one do you think? Like, what would it have to be an experiment?
And basically interchangeable.
We'd have
In
to
this
manipulate something, wouldn't we?
Oh, my God.
Wouldn't we?
Not necessarily.
No. Oh. So you think it's an experiment that won't be able to prove anything? Especially
colloquially-
whether
Bev,
a straight
it's-
line
Bev,
or a
It's a
curve.
colloquialism. Test and experiment are interchangeable.
Oh, is
This isn't
it?
a scientific debate.
Okay.
This isn't scientific terminology we're using here. I'm not doing my Viva.
He obviously doesn't know the definitions there, then, does he?
Is it geometric then? Oh, is that what we're dealing with? Straight lines and curves. Is that, would you call that geometric rather than scientific then?
No, I'm not using complete scientific language. I'm not defending my thesis here. I'm not speaking as if I'm in a Viva.
Okay. Can you have a look at me water level test, will you? Quite proud of
Yes,
this.
I can see it. You'd
Right.
see the same results on either one, Bev. That's your problem.
What
Globe.
that
Globe or flat, these will show the same results.
that would
is your
show
problem.
a horizontal water level, wouldn't it?
No, because the water surface will follow the gravitational equipotential.
Oh,
This is your problem. Your
My
experiment,
problem.
test, whatever you want to call it, shows the same results either way. There is no differentiating factor between the two. You are not proving anything here.
well, one's
Because
a
there is no
curve or a
there is
straight
no ex-
line. There is a difference
there is no
between a curve
expected
and a
difference.
straight line, isn't there?
There is no difference in expected results. That is your problem.
There is, because one of them's a curved line and the other
But
one
how does
is a
that present
straight
itself?
line.
How does that
Geometrically,
present itself differently in your water level?
because
What is the difference between the water levels?
can you see can you see them? Like, actually, can you see them? Are
What
you
do mean?
looking?
Can I see them? Yes, I'm looking at your little diagram.
Right. So you can see the black water level. It has a little, I've added a little doody T-junction in the middle of it. Right?
Yeah.
Right. So the water, when you fill that up, the water level equalizes to a horizontal condition.
Unfortunately for you, on the globe model, that equalizes to gravitational equipotential.
Right. But so what?
Both will show the same results.
Right,
This is
listen,
your problem.
Nick.
You have no differentiating results.
Nick, you've not let me finish yet, have you? So
Carry
the
on.
black one, across them 3 tubes, the water level would be horizontal. They would all be the same level. Right, now, the 2 red ones are completely separate. Absolutely separate. But they only go halfway across.
No, you
Yes.
still have the same problem. Gravitational equipotential. You will show the same results for this experiment.
Well, no.
Which either is true.
A horizontal plane of reference would show that if there is a difference in the...
What the surface of the water, break this down to the very basic level, the surface water of those tubes, what is the difference if it's a globe or flat? What are the differences?
See, I don't think you understand what a water level is, Nick. I think you've got really
Water level,
really
water level,
confused.
no. Your water level is going to level out to be the same height. In that is that they're reaching the same point of gravitational equipotential.
Yes.
Yes.
You do understand
Which is your
that.
problem, because gravitational equipotential is curved around the Earth. As such, you will see the same results on a globe and flat Earth. This is what you're not understanding.
Yeah,
You
do
will see the same
understand
results
the
on
difference
both.
between a straight line and it. So
It makes no difference for your test.
So
That's
you're
the problem
saying
with
that
God.
if you were to do a water level test on the globe, this is exactly what you would draw, is it? Because you seem to have
No, the surfaces
a
of the
different
water.
idea.
No, listen. The surfaces of the water would be at the same height from the ground.
a lot of your people that you know on your side would imagine that curves, wouldn't they?
It does
'Cause
curve.
we-
I've never said it hasn't.
That
I'm
looks
saying
like a straight line,
No,
doesn't it?
Listen,
Nick,
I'm saying you would see the same results. The surfaces
that's a
of the
straight
tubes of
line,
water.
Nick.
Listen, the surfaces of the tubes of water will show the same results because your gravitational potential you're following,
So horizontal
which is a curved
frame of
Gravitational
reference.
equ-
No, the
no.
horizontal
gravitational
doesn't curve.
equipotential. Gravitational equipotential is what you're following with that.
Right, so gravitational equipotential is what curves the horizontal. I did say this earlier,
No,
didn't I?
that's what your water level's
You would
following.
be,
Doesn't
making
gravitational
an effect
equipotential?
bend
You are
a
following-
straight line. It's fantastic.
You are
Nick.
following gravitational equipotential with the surfaces of those water. They will follow the same height from the center of the Earth. They will follow gravitational equipotential. They will equalize P equals mg delta H across the entire system. You would see the same results on a flat Earth and the globe. This is your problem. Your results-
I don't have
yeah.
a problem. Straight
The
lines are
problem for your
straight for me.
test-
I don't have any problems.
The problem for your test is that it doesn't differentiate. I congratulate you for attempting to do an experiment test, whatever you want to call it. The problem is you don't have a differentiating factor between the two things you're testing.
3 different water levels there, Nick.
No. Differentiating factor is the difference in results expected. You
Pardon?
cannot say, with reference to the surfaces of those water,
I have to expect
me-
different results, do I?
yes, to prove one thing,
Can
you
I
have to
not
have a
just
set of
do it
expected
and then
results.
see what happens? Is that not
Yeah.
how it works?
You're trying to differentiate between the globe and flat Earth,
I'm
whatever you want
just
to call
showing
it.
there's a test that I think can show a difference between a curve and a straight line.
You need to say what you think that difference
no,
is.
it's fine. Nick, it's fine. You don't know.
You cannot state a difference in your test between the expected results. This is your problem.
What expected
If you cannot
results,
state that
Nick?
difference, your test is void.
Why do we
What you're doing-
need to have expected results? What
Stop
are you
saying
talking
it's gonna
about? Why can we not just do the test and see
Because
what
you
we
do
see?
tests based on expected
What,
results. You go,
what
"I think
happens,
this
Nick,
will
if it
happen,"
shows
and then
there's
you
a
test.
curve?
what you do is you go, I think this will happen if I do this. I'm going to test it. The problem is you have no expected results. The results you're going to see would be the same on a flat Earth and a globe. You cannot differentiate the results.
You can't differentiate. I've set a test
No,
up that I
because I
say
said they're not
can.
different. The results aren't different. You need to explain to me how the expected results are different. With reference to those
curves,
surfaces
Nick,
of the water.
The other one doesn't. It's horizontal.
No. With reference to the surfaces of the water in those tubes, what are the expected differences? You've got nothing.
Okay, right. So
You don't prove anything either way.
Let's start at one end of the canal, right? And then 2 miles away, where's that water level?
What?
What is it horizontal? Is it in the same level or is it lower?
It's following gravitational equipotential.
Yeah. Does it follow gravitational equipotential to a lower height?
It's not correct to say that on a globe.
All right. So it would be
Lower
horizontal
height
then, wouldn't
measured
it?
with distance is measured with distance from the center of the Earth out to the radial point.
What is?
What height is? It's measured from the center of the Earth and a radial point out.
Nah, it's above sea level, isn't it?
Yes, which is measured. Sea level is measured from the center of the Earth to a radial point, and then you subtract that. But it's the same thing.
Really?
It's just you subtract a number. Yes, above sea level.
Yeah,
And
I
from
know
the centre of
above
the Earth
sea
are the
level. I
same
know
thing.
they do that. They get sea level and then they just measure horizontally, don't they?
It's similar to Kelvin and Celsius. You just subtract a number to get from one to the other.
What, from sea level to what?
From sea level, you'd add whatever the distance is from the center of the Earth to sea level. I don't know that off the top of my head.
Wait, we just
it's
calculate
around
sea level, don't we? We just go from sea level, right?
Yes, which is a distance from the center of the Earth radially
So
outward.
that level that you're thinking of there, does that curve? Because that's sea
It follows gravitational
level.
potential round the Earth.
Yeah, so that level is horizontal, right?
No, it follows gravitational equipotential around the Earth.
Okay, can please define level?
It's equidistance from a point or surface feature
Okay,
or
so
line.
imagine I'm surveying, and I'm surveying a point 100 meters away. What do I need to know when I'm getting my level out and setting my level up?
Small scale. You can approximate it to completely flat at 100 meters. It's irrelevant.
Oh, so that is flat.
'Cause it's so small.
Why'd you say flat?
No. Because it's so small,
Yeah.
you approximate it to flat because the
No,
curve
no,
is
you
completely irrelevant.
approximate it. You
The curve is
exact it
about
to
half a mil.
horizontal, don't you?
Sorry?
You exact it to horizontal, don't you?
No, you approximate the curve as horizontal. Because it's such a small scale, the curve is irrelevant.
Right. So you are saying that the horizontal is a curve, right?
No. You can approximate the curve and just assume it's horizontal because the effect of the curve is nothing. The effect of the curve becomes negligible at such short distances.
We're not talking geometric here, though, are we? I mean, this is fantasy, isn't it?
No, this is what surveyors do. So at work, I use something called the T3000 Lucia Wild theodolite. This has a mode setting in it to turn off and on curve compensation depending on the distance you're surveying. T1000, T2000, T3000 all have this mode, and it's dependent if you want to include the curve in your calculation or not. Now, whether you want that on depends on the distance. Now, I don't use these for surveying. I use them for optical testing because they're really good at measuring angles. But I know all the settings of them and how to use them.
Right. So
Why would they have this?
it has a
If they-
like a theodolite is you look at something through a scope, right? Just to
Yeah.
explain to everybody, you set it up, you level it up, and then it can define angles in the upwards and downwards direction and
So
left to right, right?
So T2000 and 3000 are digital. These can measure distance for you. They can do a load of stuff from the
Do
angles.
everything automatic. You press a button.
Yes, the T2000, 3000. You point it at a point, click set mode. I think it's 861 run, and it will save that point. Point it at another point, and it will give you the distance between them and give you measurements.
Cool. Is that like one of them things you can strap on the top of your car and go surveying with driving with your car?
I don't use them on cars. I believe they can be powered from car batteries. I'm not 100% sure.
No, put them on the top of the car and drive around with them. Can you?
No, not at all. You need to be looking through them.
So you need to optically look through these things like it's a telescope, right?
Yeah,
Right,
we
okay.
use cameras.
And then when
yeah.
you switch the on and off curvature adjustment thing, does that, like, what you're looking at change?
No, it's calculating the distance from you to an object. It
Right,
will
so
include
the
the calculation of the curve or not.
Okay, so
But
the
because the
distance
distance
between
is so
you and the
small-
object, right, changes if you can flick a button. It will change the distance to make it like you are on the curve or like you are on a flat. Which one?
So
Does it alter from
Either
which
way,
one to
it's a
which one?
toggle. It's a toggle between the two.
Well, which
the thing
one?
is, on a very small
like,
scale,
both can't be true though, can they?
No. On a small scale, the curve doesn't matter. If I'm surveying, I don't know, 100-meter squared area, it's irrelevant, the curve.
You do often
Because it's negligible.
survey 100-meter square areas, do you?
Yeah, and well, I don't.
Oh,
But at that distance, the curve is negligible.
okay.
The curve would be. I'm trying to do maths in my head here. I can't do trigonometry in my head. Can't do sines. I can't do that in my head.
Okay. No, but nobody's
But
asking you
it
to.
wor-
Have you
it
ever
works
measured
out as-
anything? What did you measure at 100 meters curvature?
No. This is an example.
Oh.
You don't need the curve at that distance.
Wait a
because
minute.
distance is
You've got a
50
theodolite
microns.
at your place that can actually measure curvature, but
Yes.
you've never pressed the button to do that.
We don't use them for that at work.
Ah, but
We do
wouldn't that
optical
be
testing.
cool? You should ask them next time if you can do it. Just at dinner time.
We point.
Can
them
I
at
go out
stuff
here and
for
measure the
aircraft.
curve?
No, they cost like 10 or 15 grand. Fuck all. Are they letting me take it out of the building?
Well, you can measure the curvature in the building then. Have you not got any 100 meters?
These things are set up against walls because they're used to test things.
Oh, the
Like,
theodolite
something
set
goes
up
between
against
them.
the wall.
So you have an object. We use optical things that have focus distances out to infinity, and you position that to theodolite. So it doesn't matter. There's a wall behind them, and it's more space efficient to put them against walls. It's simple.
Brilliant. Okay, but
So they
okay.
can't measure curve then.
Well, there's
Only in the building.
yeah, there's theodolites out there that can measure curve. Brilliant. That's
No. They take into account the curve when calculating the distance to an object.
can you
So they
can you just give us the name of that thing again?
Lucia Wild T2000 and T3000.
Lucia Wild.
It's like Wild, something like that. It might have an E on the end of it.
Wild. What was it called? Give us the number again.
T3000 or T2000. They're very old now.
Oh,
Very old.
digital.
All their new ones are
Can't be
digital.
that old. Oh, the new ones are digital.
Their new ones don't use rotary encoders, and we need rotary encoders.
Okay.
So
Okay. I'll have a look at that when we go searching with the surveyors.
I doubt surveyors will use them anymore. They're really old. They're from like the
Bev,
80s
can you
at
just
this
get him
point.
to spell that Lucia?
Can you spell
Just
Lucia for us?
No.
Oh,
Well, that's
I know
handy.
You were saying you're not so good at spelling. L-U-C-I.
No, I'm not good at spelling.
Lucy-
Thank you for taking the
Lucy.
piss out of disability.
Pardon?
I was making a joke, don't worry. If you search T3000 theodolite,
T.
they come up.
There you go. Sweet.
Yeah, just search T3000 theodolite.
Okay.
And they'll come up.
I'm interested in the curvature switch, but we'll do that.
It's just
well, just-
taking it to account in its calculations.
But if that has a
it's just-
curvature switch and a curvature flick, right?
Yeah.
Then how can my test not measure the curvature?
Because your test shows no difference between either model.
Why?
There is no, because your test follows
But
on
no, Nick,
your idea of
Nick,
Let me
we're
finish.
not- no,
Let me
yeah,
finish.
but we're just
You
testing
said why-
reality. We're not
No,
doing
you said
testing
why.
models.
Let me explain. Let me explain. Your idea of the Earth has a horizontal plane. So you see horizontal surfaces of those
Just
tubes.
reality, Nick.
Now, no, the globe follows gravitational equipotential, and you see flat surfaces along gravitational equipotential, which is at a 90 degrees, not 90 degrees, it's parallel to the surface of the Earth.
Yeah, he
Which
doesn't
means that you don't see a
understand
difference
that.
in results either way the Earth is. This is
Yeah,
the
he
problem
don't-
with your experiment.
Yeah, he doesn't
There is no
understand that.
difference.
He's muted you, Brenda. He doesn't talk to anybody, so
Oh, I did. I
he
talked to
doesn't
people last
understand
time,
lots.
and it was just people shouting.
yeah.
So
Brenda
didn't
would
want to do that.
definitely do that to you. It's a good, wise choice for you to do
What
that.
would I do? What would I do?
I just can't be bothered to deal with that many people
He
again. It
can't
gets
be bothered
boring.
with you, Brenda. Can you not hear him? Brenda can hear. You can hear.
They should be able to hear me. I've only muted them. I haven't deafened them.
Sounds like he's scribbling.
Yeah, he wants to be
Sounds
called
like he's
Beelzebub,
playing-
which is
playing with his
Oh,
crayons.
that was. Do you remember Sal, a flat earther from ages ago?
who?
In that Sal, flat earther in that Mega Fred from ages ago. I think his account got restricted or something. He called me that. My username is what it was on here,
Yeah,
and then he said he called me that. I found it funny, so I changed it.
yeah, brilliant.
That's where that came
It's
from.
hilarious, isn't it? Beelzebub.
Yeah, I found it funny. 'Cause he was calling me the Antichrist, and I found that hilarious.
So, Bev,
Just funny.
Brenda, he doesn't want you joining in because he'll get awfully upset if other people start talking. You know, you don't know what these Globers are like. They're terrible.
No, I did that last time, Bev. I
I'm
just
a
don't feel like
Glover.
doing it again. It's fairly simple. It wasn't fun talking to like however many people it was. I think it was 4 or 5 people. It just wasn't fun.
Yeah, it was just a casual conversation,
I'm-
wasn't it?
I'm a Glober.
No, chocolate kept fucking shouting. That wasn't fun. So
Yeah, it doesn't matter, Brenda. It doesn't matter. He's a bit of a snowflake. He doesn't like anybody talking over him.
no, I don't. Nobody does. That's just human nature.
Yeah, you do that a lot, Bev.
Sorry?
Nobody likes being talked over. That's just human nature, Bev. And no, I just didn't find it fun last time with how many people there were. That's why it just wasn't fun for me.
Okay.
And why would I spend my spare time? I mean, I still have to go to work at the moment, so it's not like I have infinite free time.
Oh,
No, Bev, you talk over people an awful lot.
So why do something I don't find fun? Talking to one person's fun. Talking to loads isn't. Simple as that.
Yeah, you know, you've got a bit of backup here. Did you call for that, Nick? Or is it
No, I didn't at all.
Brenda?
If they join the voice chat, I'll mute them as well. I asked for a one-on-one.
Yeah. See, Brenda,
So
you're not needed. Nick can survive all on his own here. Can't you, Nick?
Well,
yeah,
I'm
I
not
asked for a
here.
one-on-one.
I'm not
So if
here
they
to
join,
back him up.
someone joins from my side, I just mute them.
Yeah. Yeah,
the same as I
what are you
do.
here for, Brenda? I've been told, Nick's
No,
been
I was
told to
just
mute you.
interested. I was just interested. That's all.
Well, the agreement was a one-on-one. It'd be unfair if that was one-sided. I didn't ask anyone to come here, so
No, this
it's
is
a one-on-one.
this is what we
Unless
do
you
here.
want more people.
Yeah, we just chat here though. I mean, this is what we do. It's open. Anybody can come and have a chat with us about anything, really. It's like you want your super snowflake rules.
No, I just want normal debate rules, which isn't like 16 on 1 or however many people are
Nick.
here right now.
Nick, I know you've got your everybody muted, but nobody's talking over anybody. Even Brenda's coming. She's not trying to talk over anyone.
Oh, you said that last time, and then what happened when that chocolate guy joined?
Chocolate,
Jesus.
yeah, he's known for
Shut
being
up.
a right rumpus, isn't he, Chocolate?
Anyway, yeah, your test won't show a difference in results either way. That's your problem you've got.
Okay. Well, no, that's just
That's
your
it.
point of view, though, isn't it? Like you're
No,
not.
that's
That's
factual.
not a point of
You,
view.
you have not. You cannot state a difference in expected results.
So you're speaking for all of the globe believers, then, are you? For your.
Can you state a difference in expected results?
Well, no, because it's a test.
There you go. There you go. That's it.
It's a
That's it.
test that
But
we
your
are
test doesn't
just
prove
going to
anything.
find out what it.
But your
is-
test can't prove anything because there
Would
is
it-
no difference
You
in
would be
expected
able
results.
to see if there was a curvature in it. It would. That's what my
No, you
test is
couldn't.
designed
wouldn't,
for.
because
No,
you
you
have no
couldn't.
reference. you have no reference between the extreme left and right end. That's your problem. There is no reference you have.
It works.
You have
works
nothing
without a
tying
sight
the-
line. What are you talking
Now-
about?
If you want to
Level.
make this test prove something, you can do it quite easily by shining a laser aligned with, say, the left-hand end to the right-hand end and seeing where it falls. That would prove flat Earth if the laser came in at the same angle as the
Okay,
surface.
so a laser is horizontal then. When you level a laser, that would be horizontal, would it?
Ignoring divergence, say you've got the correct laser, yes.
Right. So that horizontal is horizontal. That
Horizontal.
That horizontal doesn't curve.
To that point on the globe.
Right. So the light, the horizontal light, might curve, mightn't it?
No, light doesn't curve. We're not near a black hole.
Right. So light doesn't curve.
No, but it will
Ever?
only be horizontal.
Nick,
It will
ever?
curve around a black. There's refraction, but
Oh, that's
That's
not
not
curving
curving.
light, is it? That's straight light.
no, that's straight lines meeting optical interfaces. The only way to curve light would be round near a star or something of sufficient gravitational mass. But that's not going to happen on
Oh,
Earth.
so it happens angularly, then, does it? The divergence of
What do you
light,
mean?
refraction. That happens. That's an angular change, is it?
Yes.
Okay.
But if you get lots of small changes and add them together, it appears as a curve.
Oh.
Lots of small changes will appear as a curve, but it is instantaneous angular changes at optical
Right. So an
boundaries.
angle is a straight line to a straight line, right? You know, like that's what an angular change means. Is it's not a curve change, is it? It's an angular change at an angle from a straight
Yes,
line to a
but
straight line.
that's-
Yeah.
How is this related?
Well, because we were doing this a bit before. I'm not so sure whether you got it or not.
No. There's a very much a difference. What we were talking about earlier was the parabolic mirrors. It's not a refractive matter. There's a big difference there.
Well, you said about like we were just going over the horizontal laser light being horizontal, and that horizontal being a
It is
straight line,
horizontal.
right?
No, it is horizontal to a point on the Earth, not the entire Earth.
But it is horizontal being a straight line, right? That's
Yes.
what horizontal is, yeah?
Yes, but it's only horizontal to a point on the
What do
Earth,
you mean
not the
to
entire.
a point? It's a horizontal line
It's a
is a straight
curve.
line, isn't it?
It's on a curve. It's only horizontal to a specific point.
No,
It's on
see,
a curve.
when you have a water level, where are you thinking or imagining that point that it is horizontal to, please?
Water level is
Yeah.
horizontal to the point that is directly above.
Directly above?
So the surface of the water will be approximately such a small scale as say horizontal. The surface of the water will be horizontal to the point directly above. Now, on a small
What?
scale,
No, you're going to have to explain that a bit
Let me
better.
finish.
No, which point that it is directly above? What are you talking about?
So these actual.
I'll put up the water
the
level
little
again
tube.
and just
I know
remind you,
what a
it's
fucking
just a
water
big
level is.
tube of
Yes.
water, right?
It is not horizontal. It follows gravitational
Right. So
potential.
where
Individual
is
points
the point that it is
Uh,
horizontal
directly-
to?
Okay, so your surfaces of the water in the tubes, the surfaces at either end,
Yeah.
those surfaces will be horizontal to the point of the Earth directly below them.
Right. So 2 points on
Yes,
the
so they
same
are two different
horizontal, right?
They are not the same
Okay.
horizontal.
So if I was to drop a plumb bob right down on top of them 2 bits that it was horizontal, would they be perpendicular to the same horizontal?
No, because there's
no.
the curve of the Earth. You're following gravitational potential.
Brenda come to save you then in
What-
case you got it wrong.
what you aren't
I wasn't
understand
trying to save
is
anybody.
that there is no down, no one constant direction
Right,
of
so
down.
which one of them would be vertical and horizontal perpendicular then? Which, of the
They'd-
two at either end?
They'd both be horizontal to the point on the Earth they're above.
They would be perpendicular too as well, would they?
Perpendicular to what? Sorry.
To the horizontal, like the vertical, the plumb bobs that are hitting
Yes, but that's only at the point.
only at which point?
At the point that the plumb bob is dropped.
Yeah.
Because the Earth is curved, it will not be vertical to every point
Okay,
on
so
the Earth.
them horizontals would intersect then. Is that what you're saying?
Yes.
Right, so
Because the horizontal is
therefore
different
there
depending on the
must
point.
be a rise in the middle of it, and my water test would be able to show that.
No, because the problem is your one's in the middle, also affected by the changing gravitational equipotential
and
that follows the curve of the
the
Earth.
only way geometrically it could happen then, with verticals being horizontal perpendicular, it would be if they were all on the same horizontal. Surely.
No.
Yeah,
You're not
I
understanding
think
is that
so.
gravitational
That's what the
equipotential
horizontal is.
curves with the Earth. No, gravitational equipotential curves. Horizontal is defined by the position of the observer or plumb bob or whatever, because using the word observer, you're going to say there's no people involved, no doubt.
Well, it's a water
changes.
level. You don't know how a water level works.
Yes,
You
it's
have to
the
explain me
surface of the
again.
water in the tubes follows gravitational equipotential. It
Yeah.
finds the points of gravitational equipotential, which is, on a small scale, approximately a horizontal. And that's a very important word there, approximately.
Yeah, geometrically. I mean, that's
No,
that's
no.
all you've got to go from, isn't it, really?
What do you mean, for what? Or you've got to go for what?
Well, how are you going to describe all of these things? I mean, like, I'm describing them vertical and horizontal and perpendicular. That's
They
sort of
change based on the position of the
straight
observer.
lines and geometry, isn't it?
They change based on the position of the observer. It's a lot more-
Even you were talking angles of change and stuff. That's geometry, isn't it?
The position,
Like when you draw a line and
changes
measure it,
depending
that's
on the
geometry.
observer. Where horizontal is, changes, depends on the position of the observer.
Sorry, say that again.
The horizontal plane
Yeah.
changes based on the position of the observer on the globe.
So
Yes.
if I have a horizontal plane, right, and it's there, then I can make that change because I move.
The horizontal that you perceive will change.
Perceive.
Yes, because you're moving. So
Okay. So
if you're,
so I'm at the side of a canal,
Let me explain.
and I'm looking at the canal, and then I move a bit. Does that make the canal move horizontally?
No, it changes your horizontal. The canal has always curved to follow gravitational equipotential.
So it is curved. You are saying it curves.
Yes, following gravitational equipotential.
Right, okay, so then my water level test will be able to find out how much that curve is.
You need to explain how. How is it doing that?
But once you understand how water levels work and
No,
link that to
Don't say
geometry, I
No,
will explain it to you,
precisely.
but you seem to be
Explain precisely.
very
Just go explain.
struggling.
Explain precisely how it shows that.
Because the
Use your words,
horizontal reference frame between the levels... Yes? Are you with me?
Yeah.
Well,
Keep
the
going.
horizontal reference frame in the levels shows that the big one is a horizontal reference frame. Now, the two smaller ones that are inside it have the same, or will have, a similar horizontal reference, except they only go halfway.
Yes, this is your problem. They
It's
are
not
following
my,
gravitational
no, it's not my
equipotential.
problem. This is a test.
Yeah, no, this is the problem with your test. They are following gravitational equipotential, which means they would be the same
Which
on a
means,
globe.
what does it mean?
They'd be the same on a globe. The results
what
you
do you
would see
what,
are no
what does
different.
gravitational equipotential mean?
So
Other than
gravity-
just saying words, can you please explain it?
Yeah,
So,
yeah. No, sure. If you don't understand it, I'll explain it. Gravitational equipotential is the potential energy from gravity at a given distance from the center of an object. So potential energy is equal to mass times gravity times the change in height.
is that space-time curvature?
It doesn't need to get that complex.
What do you mean?
You don't need to go that complex into physics for this.
Right. So what sort of gravity are you using then?
What do you mean? What type of gravity?
Exactly that.
No. Yeah, what do you mean? There's gravity.
Is there?
Oh,
It's just
do
one.
you differentiate between Newtonian and Einstein? Is this what you're trying to get at?
But do you not?
He doesn't know what you're talking about.
No, because they're the same. If you take Einstein's field equations,
He says.
let me finish.
Brenda says you don't know what you're talking about.
Let me say.
No, that's
If you
not
take
what I said, Bev. You're
Einstein's field
lying.
equations apply the limit of Newtonian gravity, which is low mass, non-relativistic speeds, and then apply the Ricci tensor to Einstein field equations, you get out the Newton's laws of gravitation. Now, this shows that they are the same. Just Newton was acting on a restricted view. He didn't know about relativity and all that stuff. They are the same. There is no difference between Newtonian gravity and relativistic gravity other than an applied limit on them. Mass, speed, can't remember if size is one or not off the top of my head.
Is that what makes a horizontal frame of reference curve?
No, you just asked if there's a difference for me to say which gravity I'm using.
Okay.
Do you accept, after me explaining that they are the same?
I haven't got a clue. I don't. It's
Okay.
it's an effect, isn't it?
No, listen. You just asked me to differentiate if I'm using Einstein or Newtonian.
Yeah, no, I
Do you
just
accept?
wanted
Yeah,
you
but no,
to
listen. Let
say
me answer the
whatever you
question.
said. I'm like,
Do you
I like hearing
accept,
the ramblings
with
of
my
madmen.
explanation, that they are the same?
No,
Why not?
because you just said a load of words and they definitely weren't the same.
They are the same. The difference is one acts within a restricted limit.
Okay.
So Newtonian gravity has a restricted mass it works at. If you go too high mass or too low mass, it doesn't work. And if you go too fast, it doesn't work. But this falls out of
Loads of
Einstein's
things that it
field
doesn't
equations.
work. Right?
This
yeah?
falls out. Listen, if you apply these limits to Einstein's field equations, you get these laws. They are the same. One is just a better understanding of the principle.
Okay, so it's just an effect, and if we can bring it back
No.
to
Where are you getting
if
the
we can
effect
bring
from there?
if we can
No,
bring it back
Explain,
to reality.
Your understanding of
Bring
gravity
it back
is
to
pitiful.
reality, because this is what we're talking about, the water level test, and
Yes,
the way
there is
that
no
you
difference.
can't seem to differentiate between a straight line and a curved line.
The problem is you can't explain to me how there is a difference
How
between
there
the
is a
two.
difference in what?
between the
Nick?
results, between the expected
Between
results.
what results?
If you're to your water level test on a globe or a flat Earth or whatever the fuck you want,
I'm going to do it in
how is there a
reality, Nick.
difference?
I'll do it in reality.
No, you're going to do it in reality.
Yes,
You get your results.
yes.
Okay. How do you tell which one it is from these results?
You just look
What
at
are
the
you
results
expecting?
first.
You look at the results first.
Well, after we've done it, yeah.
God, you've never done a science education, have you?
Okay, so you...
That basically invalidates your experiment.
No,
You are
no,
aware
Nick,
of that.
Nick, this is what we're trying to say, right? I've designed a test that I think will show something. Now, it's you that says you don't know what I do, that I'm going to say and what the test is going to make because I don't know when it curves
Your
and all
test
that.
will show
I'm
the same results
just
either
showing,
way.
yes.
That's your problem.
Listen, Nick. I designed a test because somebody said that teaching level is a straight line on a horizontal plane is child abuse. So I made a test.
That person is wrong.
I made a test to prove that it is horizontal level.
Okay, you're trying to
is
prove something, which
horizontal.
means you have expected results.
Well,
You
yeah,
need
we'll
expected
find out
results.
what them results are.
No,
you say
that's not
you
expected
say
results.
you say there will be no difference between reality and horizontal.
What? No, I'm saying that your results will show the same height across the water levels. There won't be a difference in
Yeah,
between expected results.
that's
for flat
horizontal,
or cone.
Nick. That's horizontal. Yeah, that's what the water level test will show. Is the water level is horizontal. That's it.
You're failing. No, you don't have different
What
expected
do
results.
you predict would happen, Nick?
There will be no difference in results for either model.
No
This is the problem.
What
This
model,
is
Nick?
globe, and then whatever flat
Right,
Earth
so you're
that
saying on your imaginary globe model, the results of my test will show horizontal plane, and that is what you would expect on your model. True?
Yes, they would show the same on the Earth is flat or the Earth is round. They would show the same results.
Okay, is that because one of them's imaginary and
No,
the other one's
because your water
reality?
level is following gravitational equipotential. This is the thing. I can predict the results using the known science.
Okay.
Can you?
But the results wouldn't be the same, Bev.
Well,
Can you predict the results?
He thinks they would be the same, don't he?
They would be.
Yes, they would be.
They would be
Between-
exactly the same, would they?
From my understanding of the flat Earth and how it's been explained, you would expect the same results on a globe and a flat Earth. Yes.
So that basically
But the
means
flat
lasers.
Earth, your flat Earth lot just shout density when I ask what gravity is.
No, Nick. See, you have a shape, and we don't. We have a horizontal frame
You
of
do have a
reference
shape.
in the water.
You do have a shape, Bev. You do have a
You don't. It's not horizontal. It follows gravitational equipotential.
Pardon?
It follows gravitational equipotential.
What follows gravitational equipotential? What does that mean, Nick?
Surface of water.
Is it
It's quite
perpendicular?
simple. What?
Is it perpendicular?
To what?
Perpendicular. Do you not know what perpendicular means?
Yes, I know, but perpendicular to what?
Like a perpendicular is perpendicular to its perpendicular. Do you not know geometry, Nick?
Yeah, you said, is it perpendicular? Perpendicular to what? What two things are perpendicular? Like, what are you going on about?
Like, what were you talking about?
I was saying that gravitational potential, the surface of the water, will be at the same height as gravitational potential. It will equal out across the entire surface.
I said, is that perpendicular?
No, it's parallel.
What? It's parallel to the surface of the water.
It will be parallel. Yes, gravitational potential acts from the distance from the center of the Earth. So yes, it's radially out. Not radially. That's wrong. Spherically outwards. It doesn't act as a radial. It's not a magnet. It's not a magnet. It's not an electrical charge.
Okay, so it's curved, right?
Yes.
You imagine that horizontal frame of reference dictated by a water level is actually curved.
Yes,
Okay.
it is curved. Follows gravitational potential, which is a curved surface.
A horizontal frame of reference is actually curved. Fine. Fine. Is that...
You're claiming it's a horizontal frame of reference. It's
It
not.
is.
though.
It
Follows
is. That's
gravitational
practically
potential.
used of you. Have you never levelled
No.
that theodolite?
Use
You do know
autocollimation.
what level means, don't you? That means
Yes.
yes.
Here's the thing. Level is not equal across the entire planet. What is flat, horizontal, vertical are not the same at every point on the planet. You're not kind of grasping this, that it changes as you go around the Earth.
Okay, I'm going to have to go for my tea in a bit now.
So am I. I've got work tomorrow.
Well, there's loads of other people willing to talk about this, so...
Well, I've got to go. I've got to
2
have dinner and go to work.
Right. Well, do you want to have a word with your other people and decide if you think that you can get a test that would prove...
You simply put a laser across your water levels. That's it. Put a laser across from one end of your water levels to the other end.
and out. Okay, so how far a distance do you reckon would be...
The longer the better.
Right, and go on then. Give us,
the
give us
shorter
the
you
distance. Give us the distance.
I'd have to do the maths. I don't
Aaron
know off the top of
Burrell,
my head.
one of the surveyors, says 1/4 mile. Do you reckon that's a good distance? Is that enough?
How accurate is your detection?
In fact,
system?
he described
How
it as like a disco ball with 1/4 mile
Here's the
horizontal
problem.
planes. That's how he described it.
The
What do you
problem
think
is
about
how
that?
accurate is your detection. If you're using photodiode arrays, you could probably
Well,
do
you'd
it
be
over
using
100
surveying
meters.
tools, no doubt, Nick.
Okay, for the laser, how far you need for the laser?
Why do you need a laser?
Across your? You asked an experiment to show the level of curve. I said
So-
put a laser across
okay.
your water levels,
Okay,
and then you
so-
asked how far do you?
Has level changed since lasers were invented? Are lasers the new standard for level? Or
Lasers will draw a horizontal plane that do not follow gravitational a horizontal plane from the point they are shone.
okay,
If you
would
align them like-
optical lasers that you look through, would they be okay?
that you look through. What do you mean?
Well, like normal levels, like a dumpy level or a theodolite level, like you have at your place?
Oh,
Where
they're
you
not
look for-
lasers, though. Sorry.
No, I know, but I'm just asking. They are
Uh,
optical. Now, are they horizontal? Because you've just said lasers so far.
If
are
you
the only
align them
things-
horizontal,
Yep.
they will be horizontal at the point. Yeah, if you've got a powerful enough scope, you could use that
Brilliant.
as well.
Now, what about a water level? Would that be
Water
horizontal?
level follows gravitational equipotential.
Right. So that not the water level.
Not the water level. Water level will be close enough on a small scale to be
Okay.
used.
Right. So brilliant. So a water level actually curves, whereas a sighting level or a laser level don't.
Yeah.
They're horizontal
means-
level, and the water
because they're not
level is a
affected by
curve
gravity.
level, right?
Yeah, level means
What
curve.
about water level? I
Em-
didn't catch that.
Bev.
Sorry, Brenda's jumping in on you there. Sorry, what was that
Well,
you said, Nick?
it's an open
No,
discussion.
I
it
didn't-
doesn't matter if
I
B8
didn't
He's
catch
just
that.
talking
Has
over
everybody-
Brenda.
if B8 has everybody
I
muted,
can't
that's
hear.
his fucking problem.
Oh,
So
no,
Bev,
no,
when
Brenda,
you
Brenda, you've been asked
What?
to shut up, please. Like,
why?
Because that's what we're doing.
Because they
Yeah.
are having a conversation. That's why.
It's a conversation.
Yeah,
So
yeah.
I know that they're having
Yeah.
a combination.
Yeah, no, it's Nick and his snowflake rules. So I'm going to be going in a minute anyway, so you can talk in a minute, Brenda. I was just wrapping it up with Nick. Is that okay? Brenda, you all right with that?
Yeah.
Brilliant. Thank you very much. Carry on, Nick.
What were you saying about water level? I didn't catch that.
I was just trying to make the differentiation between the laser horizontal level and the optical dumpy theodolite level.
Okay, so
And the
The
water level. Now,
water-
you say there is definitely a difference, right?
yes, the water level is affected by gravity. The other two aren't.
Okay.
Or they aren't on the scale of the Earth. Gravity
So
is not high enough here.
Where
to affect
is the differentiation made in the word level that changes a surveyor's level, used optically, laser, whatever, with the water level that was used way before they brought them? Is there a difference in between the two different types of tools?
They were used for the same thing. That doesn't mean that they are as good at it.
Okay.
Over a long scale,
Yeah.
the water level will not form a horizontal plane.
Okay, so
Because
what
it's affected by
what sort of
gravity.
scale would you be saying then that
Depends what accuracy you want. You
water
have to do
level
that.
does not establish a horizontal plane of reference?
It depends on what level of accuracy. If you want it down to a sixth of a radian, probably
No,
4 inches.
I would just have to. 4 inches, you'd be measurable. Well, let's
sixth of
say
a radian.
let's say
No,
2
I said-
miles. Is 2 miles enough for it to be
listen,
horizontal?
I said to depending what level of accuracy you want it to.
Okay, all right. Well,
I don't know.
2 miles.
Does it matter if
Yeah.
it, from one side of the house to the other it drops 2 microns? Does
Okay.
that matter?
Listen, 2 miles.
Right.
Yeah.
I wouldn't use a water level over that distance
No, because why wouldn't you use a water level?
because it's following gravitational potential. and
Because
won't
it
form
wouldn't
a-
have a horizontal frame of reference over 2 miles.
It wouldn't form a plane between the two. No.
Okay, right. I'm going to go now. I think I'm ready to leave it at that. I've got to go for tea. I'm being shouted at. So
Yeah, I've got to go make
See you
my
later,
dinner.
bud.
cheers, Nick. You want to unmute everyone and then you can say goodbye and thanks for not interrupting you.
I can say thank you without unmuting. Yeah, thank you for not interrupting, despite the fact I forced you to not interrupt.
Yeah, there was only Brenda really.
You understand that not everybody here is a flat earther, right?
He won't be unmuting you, Brenda.
Oh no, I have, because you were talking directly to her, so I wanted to know what was being said. Yeah, I know they're not, but I wanted a one-on-one with Bev